Assalamu alaikum. Bismillahirrahmanirrahim. Welcome to our service provider course, JNCIS-SP. We have already completed routing section, and this course have three sections basically: routing section, switching section, and number three is MPLS section. Okay, we have already completed first one, that is routing section. In switching section, we have already completed one class only. Today is the second class for Junos service provider switching. Today we discuss VLANs and IRBs. Okay, this is our today's topic: VLANs and IRBs. Okay, let's start. In Juniper network, there are two type of device which act as a switch. It's a EX series and another one is QFX series. Both are using as a switch. Okay. In my topology, this switch 1 and switch 2 is basically a MX device and it's working like a switch. Okay. And today we take another device that is QFX. QFX. Okay. So I take here the version is 20.2 QFX. Now I want to take two QFX, and that is packet forwarding engine. The number of default interface is to keep the number default. Then save. It's a QFX. Another one is QFX RE, packet forwarding engine. Another one is routing engine. Okay, same version. You have to take same version. Okay, RE and packet forwarding engine. Okay, keep this default. Then okay, let's connect. Consider this is QFX packet forwarding engine 5. Just rename this one QFX packet forwarding engine. It's a 1 and it's a 2. Okay, 2. That's okay. And routing engine, just rename it. It's just 1. And rename this one also. It's 2. Perfect. Connect packet forwarding engine and routing engine, and the interface will be internal. Interface will be internal. Okay, routing engine 1 and packet forwarding engine 1. Just type this one. Another connection, also take internal interface. That's fine. Connect this to, you can select any interface. I select here X is 0 by 0 by 0 and another one also X is 0 by 0 by 0. That means 10G interface. Okay. And for checking, you can add VMX For checking, you can add PMX. I take here 2. Prefix is PC, and the default interface is 6. You can modify this one or keep as default. So task. PC1. Other one is Kali PC2. It's just I rename it, but this is a Juniper VMX. OS version is 14.1. Okay, so connect this one. Interface is 1. Access 0 by 1. Okay, connect another 1. Access 0 by 1. Change this icon. Icon will be PC. Okay, consider here it's a switch, and this is another switch. Two switches are connected with each other. This port will be the trunk port. Multiple VLAN will be allowed through this link. Okay, and these are access device. It can be server or it can be desktop. Okay, so I configure this as an access port, and this interface configured as a trunk port. Okay, and create VLAN on this switch and test PC1 to PC2, assigning a single VLAN. They are communicating or not. Okay, so this our today's task with QFX. You can also test this one. I take here the VLAN for QFX. VLAN will be 200. My test subnet will be 200, and the IP Kali PC1, the IP will be 200, 101, and another PC IP will be 200, 102. So it's all lab. So for this, QFX, QFX2, and it's a PC1, another one is PC2. Okay. Okay. It takes time to complete the boot process. So now we start theoretical part of VLANs and IRBs. Okay. So go to our slide, VLANs and IRBs. Juniper service provider switching. Today our topics VLANs and IRBs. First one is VLAN. We're discussing about VLAN. So first one, what is VLAN? Virtual local area network. Okay. If you want to segment your LAN in multiple domain or in multiple segment or in multiple broadcast domain, you can divide in your flat or single LAN to multiple network. Okay, when you want this, you need VLAN, virtual local area network. Okay, if we deploy VLAN, your network will be smooth because in previous your broadcast domain size is large because all network is in one single broadcast domain. You divide the single broadcast domain to multiple broadcast domain or multiple subnet. Okay, their broadcast size will be reduced. That's why your network will be smooth compared to previous. Okay, so what is the overview of VLAN? Number one, here segment a single broadcast domain into multiple broadcast domain. This is one reason. Another reason is enable grouping user based on business requirements regardless of physical location. You can say you can consider one enterprise network. In enterprise network, they have different department like HR, accounts, IT, marketing, sales. You can specify those department uh, in a individual VLAN and assign respective subnet to communicate from one network to another network. Okay. Another privilege is you can establish and maintain connectivity within a VLAN through a software configuration, which makes VLANs a dynamic and flexible option. This option basically tell you can configure inter-VLAN routing to communicate from one VLAN subnet to another VLAN subnet. Okay, and see the switch port mode. Basically, we configure the switch port mode is number one is access, another one is trunk. So what is the meaning of access? Access means only single VLAN can communicate through this port. Okay. If you configure trunk mode, in trunk mode, this port will be allowed for multiple VLAN. For multiple VLAN. Okay. This is the trunk port. So see here, access mode. In access mode, default mode that connects end user devices to the network. You can connect desktop, server, laptops, printer, and other end devices through access mode. Typically transmits untagged Ethernet frames for a single VLAN. Basically, those port will communicate for a single VLAN. And the trunk port or trunk mode connects other switches, routers, or firewall to each other. Say here, multiple switches is connected with each other. So here we configure switch port as a trunk mode so that multiple VLAN can communicate from one switch to another switch. Okay. Typically transmit tracked Ethernet frames for multiple VLANs. The exception are when the native VLAN option is configured or when control traffic is sent. So what is the native VLAN? Basically, native VLAN is used to communicate between two switches, their own communication, not the user traffic, their own protocol communication. Native VLAN basically used for own switch communication from one switch to another switch. So when you configure trunk port, they allowed multiple VLAN. They allowed multiple VLAN. If you see the Ethernet frames, in every Ethernet frames that have destination MAC address, source MAC address, and in tag Ethernet, they have tag protocol identifier, priority value, CFI, and VID. That means VLAN ID. Okay, VLAN ID. So see here, 4-byte tag inserted into the Ethernet frame, tag protocol identifier, that is TPID, basically 16 bits value. Priority is in 3 bits. Basically, when you configure data VLAN or when you configure the voice VLAN, so if you configure one VLAN as a voice VLAN, those priority will be higher. So this is the priority field. Canonical format indicator, that is CFI. Basically, 1 bit is used for CFI. Unique VLAN identifier, that is VLAN ID. VLAN ID will be 12 bits. That is 0 to 4095. 0 to 4095. 0 and 4095 VLAN ID is reserved, and we can use 1 to 4094 VLAN in our production network. Most of the device use VLAN 1 as a default VLAN, but in Juniper, there is no default. Okay, there is no default concept. See here, here is it's a switch. See here, multiple PCs connected with switch. Those are associated with VLAN 100. Another port connected VLAN 200. Here is 100, another is 200. So if you, this is switch 1 and this is switch 2. So switch to switch need multiple VLAN, need to allow multiple VLAN. Okay, so for this, if you consider access mode, you can connect one switch port to another switch port, and this switch port you can configure for VLAN 100. Another port is for VLAN 200 if you have multiple VLAN. So do you think you just increase your connected interface between switch to switch? Just consider you have 100 VLAN in your network. Is it feasible to connect 100 port between switch 1 to switch 2 for traveling single VLAN? This is this will be cost effective. Okay. If I configure single port as a trunk, you can just allow those VLAN which you want. Multiple VLAN will be travel from one port to another switches. Okay. So this is the configuration of access port. It's a MX204 router. If you want to configure one port as an access port, just configure this port as a family breeze. Configure this port as a family breeze. Breeze means layer 2. Breeze means layer 2. And you have to mention unit 0. Interface mode, access. And in access mode, you can allow single VLAN. So that's why I write here VLAN ID, then VLAN ID value. So this is the sample configuration. This is the sample configuration for access port. For access port. In last class, we already show you this sample configuration. This is switch 1 Z0 by 0 by 1, which is connected with PC1. Okay, just go to switch 1, QFX, root, Juniper. QFX device and default user is root. Default user is root and password is Juniper. Okay, and BMX default user is root and password is root123. Juniper, J will be capital. Juniper. Okay. And then edit. Now I'm in configuration mode. Go to another QFX switch. User is root. Password is Juniper. CLI. Then edit. And this one is our BMS. This is root. Password is root123. Okay, CLI, then edit. Root 123. CLI. Okay. So first, check the default configuration of QFX. Just press that. It's the default configuration. Okay. Here's configuration. Basically, no need this one. Okay. Basically, no need this configuration. Extension. So you can remove this one. Just go to edit interface and delete everything under interface. Okay. So nothing here. So recheck the configuration again. All interface configuration removed. And now it's fine. Edit interface. Delete everything under interface demo. Okay. Show this place. Comment this one. Okay, good. Three. Then I edit. So for MX device, the access port configuration will be edit interface GA 0 by 0 by 1. This interface will be access. See here, just set the unit 0, family will be breeze. Breeze means layer 2. And set the access mode and assign the VLAN. Assign the VLAN. You can take this one as a set mode, just 2 line. Okay. So this is the access port configuration. If you want to configure access port in QFX device, in our QFX device, the port is XC 0 by 0 by 1. So set interface XC. Before this, you can check your Swiss interface. Run show chassis APC big status. Nothing is here. No APC is here. Okay. So again, chassis hardware. Nothing. There is no hardware. Run show interface stars. There is no physical port available here. There is no physical port available here. Okay. So this is the QFX is problem basically. Show interface stars. No interface coming here. And show chassis APC big status. Nothing. They are not taking the APC. Okay, no issue. We can check through VMX. No problem. So this is the configuration of access port. Then trunk configuration. Trunk configuration. So when you configure trunk port, just see the example. Native VLAN. Native VLAN, this is not mandatory. This VLAN is not mandatory. You can use, you can take. Okay, you can take. Just mention the interface unit 0 family base, and interface mode will be trunk, and you allowed multiple VLAN here. You allowed multiple VLAN here. Okay, so see our source one. This port will be the trunk port Z0 by 0. So go to our interface, edit interface, G0 by 0 by 0. See here, just set the unit 0 family base. This port is layer 2 and the interface mode is trunk. VLAN ID list, you write here which VLAN you allow from switch 1 to switch 2. Switch 1 to switch 2. Okay, this is the sample configuration of trunk mode. That's fine. And how to create the VLAN? How to create the VLAN? Show bridge domain. show bridge domain, how to create the VLAN, edit bridge domain. My bridge domain name is 100. See here, domain type bridge and VLAN ID is 100. Or you can take like this, domain type bridge. Default domain type is bridge. No need to configure domain type bridge. You can just set the name and set the VLAN ID. That is enough. Okay. So this is the way to create VLAN in MX device. But in QFX, if you want to create VLAN, just set VLAN. You can set the name like my topology. The VLAN is 200. VLAN is 200. So set VLAN like I set name VLAN 200 and the VLAN ID will be 200. That's it. This is the command to create VLAN in EX series switch and QFX series switch. Okay. If you configure access port, if you want to configure access port, edit interface, I see here the port is XE dash 0 by 0 by 1 unit 0 Ethernet switch unit 0 family. Yes, the family Ethernet switching. In QFX and EX series switch, I mention here family is Ethernet switching, not bridge. This is the difference. And after Ethernet switching, I have to mention interface mode. So this interface will be access. So this is the access mode, and you have to define the access mode VLAN ID. You have to define the access mode VLAN ID, VLAN members, and you already create the VLAN 200. Okay, VLAN member is 200. So this is the way to create VLAN and assign this VLAN in access port. This is the way to create specific VLAN. And if you want to associate this VLAN in access port, this is the command. If you want to configure trunk port in QFX or EX switch, just mention the interface first. Like this is your trunk port. You want to configure trunk mode, family, Ethernet switching. Your interface mode will be trunk. Your interface mode will be trunk. Okay. And VLAN. And you have to allow the VLAN members. You can add multiple. You can add specific or you can add all. So for lab, I just allow all here because it's a trunk port. Commit this one. So this is the sample configuration of access mode, trunk mode, and the creating VLAN. This one is how to create VLAN. This one how to configure access mode, And this one is how to configure trunk mode in QFX device. Okay, let's go. 800 to 1Q trunk configuration example. Okay, a few example of how the VLAN ID list statement can be used. VLAN ID list, if you want to allow only VLAN 100, just third bracket start, you will specify the VLAN ID and close the bracket. If you want to add range like from 100 to 200, just specify here 100-200. And if you want multiple range, if you want to add multiple range, this is the first one, this is the second one. Okay, or multiple range or individual, you can set like this. Okay, VLAN ID list, first one is range space, then VLAN ID space, then another range. Okay, show bridge domain. When you just press this command, show bridge domain. Bridge domain is customer. This customer bridge domain, multiple VLAN ID list is added. Okay, so here, see here, there have some difference between bridge domain and VLAN. In VLAN, you specify single VLAN, single name, single VLAN. But in bridge domain, you can add multiple. You can add multiple. Single bridge domain, you can add multiple VLAN ID. Okay. Show bridge domain, and then you can specify the VLAN ID, or you can say detail. Like if you want to verify this command from here, like Swiss one dot show bridge domain. See this command, run show bridge, run show bridge MAC table or bridge domain. You can see you are creating bridge domain 100 and bridge domain 200. All are in default Swiss routing instances. Default Swiss routing instances. You are just creating bridge domain 100 and specify the VLAN ID 100. And you attach two interfaces. You attach two interfaces, G0 by 0 by 0 and G0 by 0 by 1. Allowed the VLAN ID 100. Okay. So this is the sample configuration, and this is the verification command. Also, you can see the interface details. Also, you can see the interface details like run show interface. My Z0 by 0 by 0, this interface is trunk. This interface is trunk port. So, and one is, see here, nothing. That means it's a access. It's configured as a access port. Okay. So you can verify which one is trunk and which one is access. Show bridge domain, this is the another verification. Show bridge statistics. This command basically show you, run show bridge statistics. This command show you, see here, this is the local interface. So I'm in Swiss 1. This Swiss have two interfaces. One is C0 by 0 by 0. One is C0 by 0 by 0. This is the local interface. And another one is C0 by 0 by 1. See here, all packets counting here 0. All packets counting here 0. So I'm just sending one packet from PC1 to PC2. Just log into PC1, root 2, 3, CLI, edit, root 3, and edit. So let's place it. Again, check nothing. So take this switch PC to IP and sending packet from PC1. Okay, it's communicating, and see here you will get statistics. Okay, number one is broadcast packet. The broadcast packet number is 1. Broadcast byte, this is the broadcast bytes. Unicast, this is the unicast packet, and both two local interfaces, G0 by 0 and 0 by 0 by 1. So this is the statistics, basically. How many packet broadcast, how many flooded, how many unicast. Okay, so that's okay. Then it's a sample topology. Just consider here multiple switch is connected with each other. This is the distribution switch 1, and this is the distribution switch 2. So consider here, if all hosts participating on VLAN 10, all hosts participating VLAN 10 on AS3, access switch 3, access switch 3, become inactive. What do you need to do? Ensure that traffic sent to VLAN 10 is no longer sent to autonomous system AS3. That means trunk should no longer service VLAN 10. If uh, the end user not assigned VLAN 10, VLAN 10 packet will not travel from DS1 to access 3, DS2 to access 3. Okay. So you can modify the trunk port between distribution switch 1 and access switch 3, distribution 2 and access switch 3. You can disallow the VLAN ID 10 because there is no end user connecting on that VLAN. So just checking your knowledge. So after completing VLAN section, just this is the Q and answer section. First question is, which technology limits the size of the broadcast domains? VLAN basically limit the size of the broadcast domain. If I divide a flat network into VLAN, your broadcast domain will be broadcast domain size will be reduced. What are the most commonly used switch port modes? Access and trunk. In access port, untagged VLAN will be communicate, and in trunk port, tag VLAN will be communicate. Okay. VLAN administration and IRB interfaces. Okay. VLAN administration and IRB interfaces. So why we use VLAN administration? You can look one Cisco protocol. The protocol is VTP. VTP. VTP, if you configure VTP in your switching network in Cisco devices, Cisco switches basically, if you make one switch as a server switch and create your required VLAN, in server switch, those VLAN ID will be automatically forward to client switch if you configure BTP in every switch. Okay, this is the automatic way. No need to create VLAN in every switches. Okay. So similar protocol, Juniper use a similar protocol for similar function, but protocol name will be different. The Juniper use this protocol. The protocol name is MVRP, Multiple VLAN Registration Protocol. Multiple VLAN Registration Protocol. Just consider here, distribution switch 1 is root, and these are the access. If you create VLAN in distribution 1, VLAN will automatically forward to access switch 1 and access switch 2. But this protocol is rarely used because in our current production there is multiple vendor device. There is multiple vendor device. So in that case, there is no open standard protocol. There is no open standard protocol. So MPRP, Cisco don't understand MPRP, or you can say Juniper don't understand VTP. So because those are proprietary protocol, those are proprietary protocol. There is no open standard. So we recommend no need to deploy this one. So if you want to deploy, consider your all device is Juniper and your future plan you not interested to add another vendor devices, so you can deploy MPRP. Otherwise, no need basically. So this is the sample configuration, access mode, and basically MPRP configuration in like this. Just set protocol MPRP and attach the interfaces, which is connected between switch port. Set protocol MBRP interface G14. This port is connected with another switch. In distribution switch, two port is connected to another switch, and access to switch, the port number 16 is connected. So just add the interconnected switch port in MBRP protocol. That's all. It will work. Okay. We are not interested to deploy this one because it's a proprietary. And last one topic is IRB. Last one topic is IRB. IRB means integrated routing and bridging. Integrated routing and bridging. Consider it's a switch. This all port act as a switch. Means this is a layer 2 port. This is a layer 2 port. So you cannot configure IP addresses in this port. IP addresses in this port. Okay. So if you want to log in these devices remotely, you have to configure one IP address for management VLAN for logging this device. So this will be one purpose. Another purpose is you are just making multiple VLAN. Consider VLAN 100 and another one is VLAN 200. So you want this subnet will communicate with this subnet. So you need to make interVLAN. You need to make here interVLAN. So in that case, you have to configure one IP address from this subnet under VLAN 100 and same for VLAN 200. So you need the layer 3 interfaces. So this is the solution, integrated routing and bridging, that is IRB interfaces. You configure your VLAN gateway in IRB interfaces, and your one subnet PC will communicate with another subnet PC, or one VLAN PC to another VLAN PC. So how to make this one? Just see here, IRB configuration example. So this is the VLAN configuration. Show bridge domain, VLAN bridge domain name, the VLAN ID, routing interface. This is the IRB interface, IRB.0. IRB.0 means this one, IRB.0. So you configure set interface. Your interface is IRB. The naming convention is IRB. Set here unit 0. You can set unit number. You can set unit number, any number. You can set any number. Basically, we recommend for VLAN 100, the IRB unit is 100 for better understanding. Okay. So you can use 100 or you can use separate value. No issue. Okay. So here the configure example use unit 0 but VLAN ID 100. For VLAN ID 200 they are using unit 1. No issue. It will work. Okay. Yes. This is similar to SVI in Cisco, Swiss Virtual Interface. Perfect. So now we can go on lab and check this configuration. Okay. So see here. Uh, this is Swiss 1 and another is Swiss 2. In Swiss 1, see the full configuration. I'm just configuring trunk port, access port, and creating the VLAN. No need to, this is the optional command. This is the domain type. Domain type is the optional command. You can remove this one, no issue. Okay. Or you can keep this one. Domain type, brace. So show this plus that. Brace domain. This is the brace domain name and the VLAN ID. Let's commit. So same way, I remove the optional configuration from here. 1, 2, 3, and the CLI and edit. Remove base domain type, and another configuration is this. Commit. So the first step, creating the VLAN. Creating the VLAN. So how to creating the VLAN? Show brace. See here, this is your configuration. Okay, this is your configuration. Cross-check, show bridge domain, VLAN ID, bridge domain name, and the VLAN ID. Okay, this is the way to create VLAN ID. Okay, then mention IRB interfaces. Mention here IRB interfaces. Run show interface stars. First, check this one. IRB is available or not. See here, IRB, no here. No IRB interface is here. or you can mass IRB. Yes, IRB is here. IRB, this one. You have to check first. IRB is available or not. Okay, IRB is available or not. IRB is available. IRB must be available on your switch. Otherwise, it will not work. Okay, my checking done. Then I want to configure one IP address in switch 1 under VLAN 100. Under VLAN 100. So how to make this one? So first I have to set interface. The name is IRB and I can set the unit number, uh, any number. So I choose here like set interface. The interface is IRB. The interface is IRB and you can set here unit. I choose the unit number is 100. You can set here description. You can set here description. I set here description MGMT IP. Okay. And next step is set the IPv4 address. Valid IPv4 address. Then set family inet address. My subnet is 192.168.100.0/24. Okay, so I choose here 100.1 in Swiss 1 and 100.2 in Swiss 2. So 192.168.100.1 slash 24 in Swiss 1. Okay, so commit this one. Committed. Now check. Run show interface. Sorry, run show. It's okay. Run show interface stars mass IRB. See here, main IRB interface is up, but IRB dot 100 it's down. It's down because we have to complete. We have to attach. We have to attach in bridge domain. Okay, so the next step is set bridge domain. My bridge domain is bridge domain 100 and the routing interface. The routing interface, my routing interface is IRB 100. My routing interface is IRB 100. Okay, commit this one. Now again check the interface status. Now interface is up. So here two step. Here two step to configure the IRB. First one is you have to set one IP address. You have to set one IP address in IRB interfaces. You can map bridge domain or VLAN ID and unit number. I map here unit number 100, bridge domain 100, and VLAN ID 100. My VLAN 100 subnet is 192.168.100.0/24. I configure here 100.1/24. That's okay. IP address configuration done. Second step, go to the specific bridge domain and add the routing interface. Add the routing interface IRB.100. IRB.100. Okay. So need to check this IP. This IP is accessible from PC1 or not. Hopefully accessible. Okay. 100.1. Yes, getting that means it's working. That means it's working. So you can configure this one. You can configure switch to. You can configure switch to similarly. Okay. So I'll be 100. My IP will be for switch to. My IP will be 2. Perfect. And this will be same. Switch to. That's perfect. Just check the IRB interface, run show interface plus mass IRB. Yes, up. Or you can set this one IRB. See here, first one is IRB main interface. Second one is sub interface IRB dot 100. And see here the IP address information. And this is the routing instance is default switch and is the bridge domain. Under bridge domain 100. Just check second IP, that means switch to IP 102. Yes, it's working. Perfect. So we configure IRB in switch 1 and switch 2. And this is the verification. Perfect. And you can also check your route table. You can also check your route table. Run show route. Your IRB interface will be available in inet.0. Available in inet.0. And see the route table. This is the direct route and this is the local. Perfect. So this is the QA section, question and answer section. Which application protocol does IEEE creates as a replacement for GBRP, that is MBRP, that is equal to BTP basically. What is the expansion for the term bump in bump traffic? Bump traffic means when frame is coming in incoming interface and MAC address type will have no entry, or you can say unknown MAC address, or it can be a broadcast MAC address or multicast MAC address. Those packet or those frame will create the bump traffic. Okay. And what are the requirements of monitoring in IRB interface? What are the requirements of monitoring the IRB interface? The gateway address and IP address of the IRB interface should match for routing to occur. That means you have to assign the valid IP address from a specific VLAN subnet. At least one active port must be associated with the bridge domain for the IRB interface. Must be enable minimum one interface. So this is the Ethernet switching and VLANs. That's all. Today we discuss VLAN and another one is IRB. Okay. So it's very simple topic today. Just I review in 2 minutes. Review in 2 minutes. Number one, how to create VLAN. This is the way to create VLAN. Number two, how to configure access port. This is the way to configuring the access port and associate one access VLAN. How to configure the trunk port. This is the way to configure the trunk port. And last one is bridge, IRB interfaces. For IRB interfaces, first you have to assign the IP addresses, and second step is you have to add a routing interface under a specific bridge domain. So That's all our today's topics. Any question?
Thank you, sir, for the class, sir. I don't have any
Oh,
doubt
clear
now.
all.
Yeah. Okay. Thank you. Hope all the best.
Sir, I have
Allah
one
Hafiz.
question regarding the labs. Okay. Hello.